Good evening, St. Matthias, 7th grade math. This is your end of Module 1 assessment review. So the first question says, it is a Saturday morning and Jeremy has discovered he has a leak coming from the water heater in his attic. Since plumbers charge extra to come out on weekends, Jeremy is planning to use buckets to catch the dripping water. He places a bucket under the drip and steps outside to walk the dog. In half an hour, the bucket is 1/5 of the way full. What is the rate at which the water is leaking per hour? So the information we know is that we have 1/5 of a bucket in 1/2 hour. So in order to have a full hour, we need to multiply both of these by 2. So our rate per hour is 2/5 bucket. Okay, write an equation that represents the relationship between the number of buckets filled, y, and the number of hours. So typically the way you're going to write that is y equals mx plus b. So we're going to use the y and the x. Our starting point is 0 in this case, so we don't have to worry about that. So we have y equals 2/5 x. What is the longest Jeremy can be away from the house before the bucket will overflow? So we have, if we have our bucket, this 1/5 is 30 minutes. This is 30 minutes, 30, 30, and 30. So after this 30 minutes, the bucket will start to overflow. So anything after that. So if we count these up, we have 30, 1 hour, an hour and a half, 2, 2.5 hours. So 2.5 hours is the longest he can be out of his house for this before it starts to overflow with the bucket that he's using. All right, question 2. Farmers often plant crops in circular areas because one of the most efficient watering systems for crops provides water in a circular area. Passengers in planes often notice the distinct circular pattern as they fly over land used for farming. A photographer takes an aerial photo of a field on which a circular crop area has been planted. He prints the photo out and notes that 2 centimeters of length in the photo corresponds to 100 centimeters in actual length. What is the scale factor of the actual farm to the photo? So we have 2 centimeters to 100 meters. We can break that down and divide both of them by 2. So 1 centimeter to 50 meters. Or we can rewrite that. So if we do 50 meters times 100 to give us centimeters, that's 500. So we can also write it as 1 centimeter to 5,000, this is 0, centimeters. All right, page 2. If the dimensions of the entire photo are 25 centimeters by 20 centimeters, what are the actual dimensions of the rectangular area in meters captured by the photo? So we know that we have 1 centimeter to 5,000 centimeters, and we have 25 to an unknown and 20 to an unknown. So the first value we're going to multiply times 25. So we have 5,000 times 25. So that gives us 125,000, and we can just double check that. Perfect. And then we're going to do the same thing for 20. So I have 5,000 times 20. It's 100,000. You could also keep it in meters if you prefer. So if we did that, we would have 1 to 50, 25 to a value, and 20 to a value. And then we could do the same thing. We have 50 times 25, which gives us 1250. And 20 times 50 is 1,000. So those would be the two different options for the question, depending on how you keep it. If you have your information in centimeters or meters. All right. B says, if the area of the rectangular photo is 5 centimeters squared, what is the actual area of the rectangular area in square meters? So we would need to figure out how we got to 5 centimeters as a area. So if you remember, area equals length times width. So the area of our picture, this inside, would be 5 centimeters squared. So there's a couple different ways we could do that. We could do a little bit of guess and check, figure out what 5 centimeters squared would be. We can take the square root of 5. Here's 5, square root. It's roughly 2.2. So let's just use 2.25. That's not going to give us exactly 5, but it's a good number to work with. So if we do 2.25 squared, it's a little bit more than 5. So let's use that. So now we have, again, 1, 2, let's use 50 this time. So I have 2.25 to some unknown. We're going to multiply, since we would go from 1 to 2.25, we have to multiply 50 times 2.25. Grab the calculator for that one, just to expedite, which is 112.5. So then we're going to take 112.5 times 112.5. And again, I'm just going to grab the calculator and expedite this. So that is roughly So that would be roughly 1,265,625. All right. So number 3. A store is having a Black Friday sale. Every item in the store is advertised as 1/5 off the original price. If an item is marked with a sale price of $140, what is the original price? So the way that we need to figure this out is, there's a couple different ways. So we can do a tape diagram, and we can separate this into 5ths. So since 4 of these equal $140, we can take this and we can divide it by 4. So this is going to be 3, 12, 25. So each of these sections would be $35. Hello. So then to find the total, we would just add 140 plus 35. So the original price is $175. Okay, question number 4. Over the break, your aunt and uncle ask you to help them cement the foundation of their newly purchased land and give you a top view blueprint of the area and proposed layout. A small legend on the corner states that 4 inches of the length corresponds to the actual length of 52 feet. So we have 4 inches to 52 feet. That is what we're working with. So what is the scale factor of the actual foundation of the blueprint? So again, we have 4 inches to 52 feet. We can divide 52 by 4. So we can divide both of those by 4. So we have 1 inch, 52 divided by 4. Is 13. So for 1 inch on the drawing is 13 feet. If the dimensions of the foundation on the blueprint are 11 inches by 13 inches, what are the actual dimensions in feet? So we have our square now of 11 by 13. We said that our ratio was 1 inch to 13 feet. So we're going to use this information. So now we have 11 inches to some feet and 13 inches to some feet. So we can just multiply 13 times these values. 13 times 11. So this would be 143. And then 13 times 13, this is a square number. This is a value you should know, but I will calculate it anyways. So we have 143 feet and 169 feet for the actual lengths. You are asked to go buy bags of dry cement and know that one bag covers 350 square feet. How many bags do you need to buy for the finished project? So what we have to do here is we have to take these values. So we have to take 143 times 169. Again, I'm just going to grab the calculator over here, which gives us 24,167. So now I'm going to take 24,167 and divide it by 350. Grabbing the calculator again, just to speed up time. So this is roughly 69.04857 and on. So since I do need slightly more than that value, I need 70 bags. After the first 15 minutes of laying down cement, you have used 1/5 of the bag. What is the rate you are laying cement in bags per hour? So if we take 15 plus 15 plus 15 plus 15, this is 1 hour. So we used 1/5 of a bag for this 15 minutes, 1/5, 1/5, and 1/5. So there's 1, 2, 3, 4/5 of a bag per hour. So using that information, write an equation that represents the relationship between the number of bags used in y hours. So again, we do the y equals mx plus b. B is 0 because our starting point is 0 in this case. So I have y equals 4/5 x. Your uncle is working faster than you. He uses 3 bags for every 2 bags you use. Is the relationship proportional? Explain your reasoning. Use a graph to show your work. So I'm going to grab some different colors to show the different values. So for the So we have you using 3 bags and your uncle using 2. you using 6 bags, and your uncle uses, oh, sorry, your uncle uses 4. Okay, so this is uncle, this is you. Uncle uses 9, and you are at 6. And then we have 12 and 8. So to check to see if this is proportional, we can take a ruler or something with a flattened edge, a straight edge. Sorry, trying to use 2 hands. Line this up. 1 second, folks. Okay, so I just used the edge of the ruler, created a line. If it creates a line, it is in fact proportional. If something is off, if one of these points was above or below, not quite on this line, then it would not be proportional. 2 more questions. Okay. So, question G says, what does 0, 0 represent in terms of the situation being described by the graph? So if we look back here, where it has 0, 0, that essentially means that no bags have been used. So if my uncle uses 0 bags, I also use 0 bags. Okay, and last question. How many bags would you use if your uncle uses 18 bags? How would you know? So if we have a 3-to-2 ratio, we can do 3-to-2. So we would have 18 to some number. The way to get from 3 to 18 is times 6. So we need to do this times 6 as well. 2 times 6 equals 12. So you are using 12 bags when he uses 16. Okay, and we can use that because they are proportional relationships. And the way we can represent this on the graph is to extend it. So if we had 18 on this graph, we could extend this out and be able to extend this out as well. So since it's proportional, I would just continue on this line somewhere. Okay, so that is your Unit 1 review. Please let me know if you have any questions. Study hard, good luck tomorrow, and I hope you have a great evening.